Hey everybody, today we're solving the keys and rooms problem on LeetCode. So the problem description, they're n rooms and you start in room 0. Each room has a distinct number 0 to n-1 and may have some keys to access the next room. They give you a formal definition, but basically each room has some keys in it, and those keys allow you to enter the room with that number. So in this input here, in room 0 there's a key to room 1, and then in room 1 there's a key to room 2, and then in room 2 there's a key to room 3, and there are no keys in room 3. And they want us to return true if and only if we can enter every room by starting in the first room. So you return true here because you start in room 0, you can get into room 1 with the key, and then once you hit room 1, you can get to room 2, room 3, and then you've hit all the rooms. Down here is false. We start in room 0, we have a key to get into room 1 and room 3. Well, if we go to room 1, we can get into 3, 0, and 1, but we can never get into room 2. And the same if we go to room 3, we can get in room 0. So there are a couple different ways to think about this problem, but basically it's a graph depth first search problem. And however you want to do it, you basically need to make sure that when you run depth first search, you mock this problem up as a graph. And when you run your depth first search with the start node as 0, the node 0, you can reach every room. Basically, the graph is connected. So let's take a look. Down here is the initial function we're given, can visit all rooms, and we're given a list of integer, which is this. Basically, the keys that are contained in each room. So what I did was went ahead and made a graph class, which uses a node class to represent this problem. So here's the node class. It has members, state, value, and then neighbors. State is 0, 1, or 2 to represent if the node is visited or unvisited, visiting, or visited. And then value is just the node's value, 0 through n-1. And then neighbors are the nodes that it's connected to. And in this graph, 2 nodes are connected if that node has the key to the other room. So in this graph, 0 and 1 are connected, okay, and then 1 and 2 are connected, and then 2 and 3 are connected. This 2 contains a key for 3. That's how they're connected. Now down here in the graph class, we keep a map of integer to node, and in the constructor, we take how many nodes there are, we initialize the node map, and then make a new node for each node that we're going to have. Now we build the graph out of this list of integer that we're given. So we loop through the rooms. The current room is the room I, the index, and then we get the keys that that room contains. And then for each key that that room has, we add that neighbor. So that's how it's connected. And then the way I decided to solve this problem was checking the connected component count. So another way you can word this problem is once you have it framed up as a graph problem, basically it's saying that the number of connected components in the graph is 1. Okay, so every node is reachable from the start node. There's 1 connected component. So the way you do that is you initialize your count of connected components here at the top. And then you loop through all your nodes, and when you find one that is unvisited, you run depth first search from that node. And in the depth first search, all you really do is you mark each node that is able to be reached as visited. And you update your count each time, and then you return the number of nodes that you found. Or the number of connected components, rather. And then down here, the way we know if this problem is true, whether or not we want to return true, is if the connected component count is equal to 1, meaning all nodes are connected. And that's all there is to it. So once you mock it up as a graph problem, you define your node class and your graph class accordingly. It becomes pretty simple. You just run through depth first search, and count the connected components. There are other ways to do this, like you could keep track of a visited set and make sure that you visit each neighbor from the start node, but the connected component approach is one that can be used for other things, other problems where you might need a connected component. So you can take this graph and node code and apply it directly to another problem where a connected component count would come in handy.